All right, so rational expressions, fraction expressions. Finding the domain of those things, that's the things that X, the restrictions on the X values. To find that domain, you got to do that before you simplify. And so when we're looking at that, let's look at just a rational expression, X minus 7 parentheses, X minus 1 in parentheses, and then over X minus 1, X plus 3. So there's a rational expression. It's a fraction. You got stuff on top, you got stuff on bottom. When you're finding the domain of that, the domain is the red flags that come up. Remember, there are only 2 red flags that can happen. One of those red flags is that there's square roots in the problem, and then there's x's in the denominator. So this one, it's a fraction. Rational expressions, we're looking at things that have x's in the denominator. So to find the domain of this, we're looking at the bottom part. So when is the bottom part equal to 0? That's what we've got to find. So before we do any simplifying, we're going to set the denominator equal to 0 to solve it, to get the restrictions on the domain. Okay? Well, it's in factored form, and when you're solving things that are in factored form, you set each individual factor equal to 0 and solve it. So we're just going to set x minus 1 equal to 0 and x plus 3 equal to 0. And get x by itself in each one individually. So plus 1 minus 3. So x is equal to 1 and negative 3. Those are the things that x cannot be. Those are the restrictions on the domain. All x's, as long as x does not equal 1 or negative 3. Technically, I guess it should be negative 3 or 1 if you put it in order. In interval notation, that would be from negative infinity to negative 3, union, negative 3 to 1, union, 1 to infinity. So that's just saying I went all the way from negative infinity until I got to negative 3. I skipped it, went from negative 3 up to 1, skipped the 1, and then keep going to positive infinity is what that's telling us to do. That's the domain of that rational function. Okay? Now, the simplifying is where the factoring is important all over the place. Okay? So this one is already factored for us. So what we look for is matching factors, things that can cancel. So what are the matching factors on the top and bottom? The x minus 1s are the same. They cancel each other out, leaving us the simplified version, x minus 7 over x plus 3. Notice the domain gives us 2 numbers that x can't be. If we had used the simplified version, we'd only get 1 number that x couldn't be. We've got to find domain before we simplify, or we lose part of the things. That could be a problem. Okay, so you've got to go from based on the original. That's what you got to go off of. Don't go off of, for domain, don't go off of what you simplified to be. Go off of the original. So we find the domain before we simplify. Find the domain before we simplify. So let's look at another one. We're going to find the domain. And simplify. So let's say we had x squared minus 6x plus 5 over x squared minus 25. We have a rational expression. This one is not factored for us. They asked us to find the domain and simplify. So the first thing we're going to do is find that domain before we simplify. If they wrote the directions in the other order and said simplify and state the domain, we still do the domain first. Domain has always got to be done first. Okay, so we're going to set what part of that equal to 0. X squared minus 25, the bottom part. Here's where you got options as far as solving this, but the most logical thing that you can do is factor it. because we're going to have to factor it in order to simplify anyway. So we want to try to use factoring to solve this. So it's got two terms, a minus sign in the middle. We got an x squared and a 25. I'm thinking it's a difference of squares. What squared gives me 25? 5. So that means this thing factors as x plus 5 and x minus 5. That allows me then to set each of those factors equal to 0. Subtract 5. Add 5. But two things that x can't be. X can't be positive 5 or negative 5. So your domain x does not equal plus or minus 5. In interval notation, be negative infinity up to negative 5, union negative 5 to positive 5, union 5 to infinity. There's our domain. Again, we're going to find that before we simplify. When we go to do the simplifying, we're going to use the factoring we've already done on the bottom. Okay? No sense in having to redo it. We've already done it once. So the bottom part factors as x plus 5, x minus 5. We need to go back and factor the numerator if possible. So the numerator is a trinomial. It's got 3 terms. I can use the x method on it. 1 times 5 is 5. Negative 6 goes in the bottom. What multiplies to be 5 and adds to be negative 6? 5 times 1 is 5. 5 plus 1 is positive 6. We need to make them both negative. Negative 5 and negative 1. Can I take that shortcut on this one? Yeah, because there's a 1 in front of x squared, so my factors are x minus 5 and x minus 1. Now, because I'm simplifying, I'm looking for matching factors on top and bottom. What factor matches? X minus 5s. So we're going to cancel these two out. That's going to leave me x minus 1 over x plus 5. There's the simplified version. Here's the domain. Here's the simplified version. That's one of the things that we're doing here. Simplifying rational expressions and finding their domains. Okay. Let's simplify a few more. 12x squared minus 30x over 4x squared minus 25. So, what do we do first to find the domain? We'll set it equal to 0 and then factor it. Be 2x 5, right? So the fact it's a difference of squares. So 2x plus 5, 2x minus 5. Subtract 5. So that'd be x is equal to negative 5 over 2, positive 5 over 2. When you do those things. Move the 5s and divide by 2.